Hello everyone, you all have just completed permutations and combination from class 11 syllabus. And this is the time to start binomial theorem where you will find direct application of the concept of combinatorics. In binomial theorem, you will learn the theorem, and today's class will know how to apply to solve simple problems. Those simple problems includes divisibility problem. So let us start without wasting our time to understand binomial theorem. Before you do binomial theorem, you must know what are binomial terms. If you have an expression like say 2x plus 3y, it may be x minus 1 by 2x. It may be 1 plus 4x. It may be even like this, x cube minus 1 by 3x square. All these are binomial terms. Why they are so called binomial terms? Because a binomial, bi means 2. So if an expression contains 2 terms, then it is said to be binomial. This one binomial because it consists of 2 terms, 2x and 3y. This one contains 2 terms, x and 1 by 2x. This one also, although 1 is a constant, but it can arise. And any index can be there in numerator or denominator, it can be binomial. So remember, for binomial, there will be 2 terms. If it was trinomial, you must have got an expression like this, x plus 2y plus 3z. But these are just expressions. Then what binomial theorem stands for, that we are going to learn. The theorem, you already have introduction in classes 8, 9 and 10. I am talking about the simple expansion where we consider expansion of x plus y to the power 2 or x plus y to the power 3. You have seen this kind of expansion. Even if you try to expand x plus y to the power 4, that also you can get by knowing the expansion of x plus y to the power 3, isn't it? Because x plus y to the power 4 will be x plus y whole cube, this multiplied by x plus y. But a problem will arise if you are asked to find the expansion, the result of x plus y to the power 20. If these indices gradually being increased, expansion becomes very difficult. To avoid those difficulties of expansion, Sir Isaac Newton, you must have heard of him. Definitely all of you have heard Newton's law of motion. He invented binomial theorem. Today's class we learn binomial theorem with this positive integral expression. I mean, where the indices are positive integer, 2, 3, 4 like this. If it is 2, then you can expand. If it is 3, then also you can. 4, 5, all these you go step by step. But problem I told you arises for expansion like x plus y to the power 20. Step by step we learn how to get those coefficients. What are those coefficients? If I show you the expansion of say x plus y to the power 2, you know this is x square 2xy plus y square. What are the coefficients? 1, 2 and 1. Similarly, when you expand x plus y to the power 3, it is x cube 3x square y 3xy square plus y cube. What are the coefficients? 1, 3, 3 and 1. So, if you have started with expansion of say x plus y to the power 0, what will you get? this was 1. If it was x plus y to the power 1, this will give us just x plus y. Here the coefficient is 1. Here you got two coefficients, 1 and 1. Here you got 3, 1, 2 and 1. Here you got 4. So indices increasing, number of terms after expansion also increasing. If it was 0, it is 1. If it is 1, then it is 2. If it is 2, the number of terms in the expansion is 3. If it is 3, then it will be 4. If you say I will write for x plus y to the power 4, then it is definitely x plus y whole cube into x plus y. And when you multiply, you get the expansion like x cube plus 4x square y plus, no, it will be x to the power 4, not x cube. So this will be, if you expand, it is coming x cube like that. You better write it once and then collect the terms together. X cube 3x square y plus 3x y square plus y cube into x plus y. So x cube with x, it will give you x to the power 4, and then you will get 3x square y plus x square y. Another x square y will be there. That is, so it will give us x square y into x, it will give you 4x cube y. This will give you then, if you collect terms, it's coming 6x square y square plus 4xy cube plus y to the power. Why I did this one, that I will explain now. But before that, you see number of terms. If it is 4, then number of terms after expansion becoming 5. 1, 2, 3, 4, 5. It was 3, then it is 4. It was 2, then it is 3. It was 1, then it's 2. 0, 1. So in any one of these expansions, if the index is 4, then it is 5. If the index something like, if we continue this manner, x plus y to the power 10, this is going to be number of terms after expansion expected to be 10 plus 1, that is 11. And if it is x plus y to the power n, the number of terms expected to be n plus 1. All these observations we will keep in our mind. Another thing, in any one of the expansion, you can see that the powers of x gradually reducing and powers of y gradually increasing. You start with this one. Here the power of x is 4. This is 3 plus 1, 4. 2 plus 2, 4. 4, 4. But x is gradually decreasing. Y from 0 here, it is increasing gradually to the highest integral index. So, some of the indices of the terms going to be equal to the index given here. As I told you, 3 plus 1, 4, 2 plus 2, 4, 1 plus 3, 4, and this 4 is 4. And the index of x gradually decreasing if you are going from left to right. It is gradually increasing for y if you are going from left to right. Now we will make another observation where these coefficients can be arranged in such a manner that we can find the expansion in any case. We can get the expansion in any case, and that is obtained by using Pascal's triangle. Let us know what is Pascal's triangle. Before you know Pascal's triangle, we just look at the coefficient. First one is 1. This you can see. Okay, coefficient is 1. Second one is 1, and this is 1. Third one, 1, We are writing this manner 2 and 1. And the fourth one, if you start writing, it will be 1. Fourth one, you just write fourth one, that x plus y to the power 3. Then this is coming to be 3. This one 3 and this one 1. Now it will be 1. Write 4 here, 6 here, 4 here and 1 here. So what I did there? I wrote coefficients only. Coefficient of these expansions we have taken here. We make another observation there that the extreme terms have coefficient 1 only. See, it is 1, 1. It is 1, 1. 1, 1, 1, 1. Coefficients are, for extreme terms, coefficients are 1 only. And another observation you make, when you are going to write terms from this row, it is actually the sum of the term immediately before it and after it. So this 2 is actually result of getting these two numbers, their addition. This 3 here is the addition of the term just before it and the term just after it in the previous row. Here also the same manner. Next row if you see, then what is going to happen? This 4 how to get? This 1 and 3 added together to give 4. This 3 and this 3 added together to give 6. So many things are there to observe. First, 2 extreme terms are 1. Secondly, any term you get which is sum of the term just before it and just after it in the previous row. Here how to get? Nothing is there means 0 is there. So 1 is 0 plus 1. Same manner, this one also 0 plus 1. I did not write those coefficients here. We have started from here. Now, by using this method, if I say that we'll write the expansion of, say, x plus y to the power 5. Let us write. We got it for x plus y to the power 4. What will happen for x plus y to the power 5? Let us check. Extreme terms are 1. So first you put 1 here and this one 1. Now what you will do? You will add 1 and 4 to give 5. 4 and 6 to give 10. 6 and 4 another 10. And 4 and 1 this is 5. You understand? These 1 and 4 added to give 5. These two are added to give 10. These two are added to give 10. This one and this one added to give 5. Clear? So, can we write the expansion of x plus y to the power 5 now? Is it true that if you write the leading term is 1 and the extreme term 1, so you write x to the power 5, this is 5, x to the power 4 y, because sum equal to 5 we have to maintain, then 10 x cube y square, then another 10 xy cube, because y gradually will increase, this plus 5 xy to the power 4 plus y to the power 5. And this is really the expansion of x plus y to the power 5. You just use little bit of inside multiplying this expression, this equation both sides by x plus y, and then collecting similar terms, you will get the expansion of x plus y to the power 5. And this triangle, this was invented by Blaise Pascal. That's why it is called Pascal's triangle. the utility of Pascal's triangle is you can write the coefficients of the binomial at any stage if you add the terms in the previous row. But there is a problem here. If it is asked to find expansion of x plus y to the power 10, then you have to continue till that. It's very time consuming. Otherwise, this is a great method. Everyone should attempt binomial expansion with this method first. Until 7 or 8, you will try to get, this will be an activity at home, to get the coefficients up to n equal to 8 in the binomial expansion by using Pascal's triangle. I hope all of you have understood this. Now, there is another way to get all these things, and that is done by using the formula you got in combinatorics. What formula is there? The formula is for NCR. You know it very well. It is factorial n by factorial r. You have just done in combinatorics by factorial n minus r. Isn't it? Factorial n by factorial r, factorial n minus r. We have planned to write all these for r equal to 1 to 3, and then you will check whether all those coefficients can be written in terms of the binomial coefficient like NC1, NC2, NC3 or not. So let us write the values of few first. NC1, this is n by using this formula. If you write NC1, it is going to be n. If you write NC2, you have seen in combination n into n minus 1 by factorial 2. NC3, n minus 2 by factorial 3. So if I plan to write all these coefficients you got by using NCR formula, that will be appropriate. It might give you easier way to expand a binomial. Let us see 1, 1. How can we write 1 here? That 1 we can write as 1C1. Okay. This one we can write, we can also write 1C0, and this is 1C1. This one, this is the row of 2, index was 2. So this we are writing 2C0. This is 2C1 and this one is 2C2. Why? You use the formula 2C0. NC0 is what? NC0 is 1. NC0 is factorial n factorial 0 factorial n. So this is 1. So 2C0 is 1. What about 2C1? Use this formula. NC1 is n. So TC1 will be 2. And this is the arrangement for index 3 over there. X plus y to the power 3. So let us write in terms of 3CR here. This will be 3C0. This will be 3C1, 3C2 and 3C3. We have used these coefficients. Why? Just check once. 3C2 is what? You put n equal to 3 over there. This is going to be 3 into 3 minus 1, 2 by 2. Factorial answer is 3. And 3C3, how do you write? 3C3 you can write as 3 minus 1, 3 minus 2 by factorial 3. This is also 1. Alright? So all these binomial expansions can be written by using the concept of NCR also. This is a row of 4. You write this one 4C0. This is 4C1, 4C2, 4C3 and 4C4. And this one is what? 5C0. This is the row of 5. 5C1, 5C2 is 10 really. 5C3 and 5C2 same. This is 5C1. No, you don't write 5C1. This is 5C2. This you write 5C3. Same thing. 5C4, 5C5. Why same thing? Because you know NCR equal to NCN minus R. Isn't it? So all the coefficients can nicely be written with the help of this combinatorics formula also, NCR. So let us write it for x plus y to the power 5. This is going to be, if you try to write, this will be x plus y to the power 5 means x to the power 5, 5c1 x4y plus 5c2 x cube y square plus 5c3 x square y cube plus 5c4 xy to the power 4 plus y to the power 5. Now if you say why you don't write 5c0, of course you can write 5c0 to get the symmetry. Of course this one you write 5c5 because 5c0 is 1, 5c5 also 1. If we plan to write say x plus y to the power 7, by this method it will be 7c0. Just once more, for you have seen some of the coefficients 1, you have seen value of x gradually reducing from left to right, value of y gradually increasing. Also you have seen one very important observation there, that equidistant terms have equal coefficients. Isn't it? You just see in x plus y to the power 4, second time is 4 and here it is 4. So second from beginning and second from the last have the same value. Second means second coefficient. Similar is the case for x plus y to the power 5. See, this one third from beginning, first, second, third, and this one third from end, 1, 2, 3. They are equal. This time it's second from beginning and this one second from first. They are equal. So equidistant terms have equal values. This also we'll keep in our mind in binomial expansion. Okay. So let us write the expansion of x plus y to the power 7. If you write this manner, it will be 7c0 x to the power 7, 7c1. Some of the indices should be 7 always. This will be x to the power 6 into y plus, you can write y to the power 1, 7c2 x to the power 5 y square, 7c3 x4 y cube, 7c4 x cube y4, 7c5 x square y5, 7c6 xy to the power 6, and the last one 7c7 y to the power 7. Actually, we'll avoid the expansion by using the way we use in principle of mathematical induction. PMI, we can use PMI, principle of mathematical induction. Right now I will avoid that proof. I'll simply write Newton's binomial theorem. I told you it was invented by the great Sir Isaac Newton. So he invented binomial theorem. It is true for any positive integral indices. What is the theorem? Let us write. The same person who invented many laws of light, who gave 3 laws of motion, which is actually the origin of mechanics, what you are doing, it may be Newtonian or rotational. The same person given the binomial theorem statement also. In analogy with 5, 6, 7, what we did, if we write the binomial theorem, it will be for positive integral x firstly, and secondly, okay, we'll make those observations. Let me write the theorem first. X plus y to the power n. N is a positive integer. Maybe 0 also, but 0 we don't need. X to the power n plus, say I am following the pattern I have used before. NC1, NC2, 7C1, 7C2. So it will be NC1 x to the power n minus 1 y plus NC2 n minus 2 y square, plus this way I write another term NCR, which will be the representative of all the term. I mean the reference term. It is NCR x to the power n minus r y to the power r plus dot 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 y to the power n. Why I am not writing coefficient of x to the power n, y to the power n? Because they are known as NC0, NC1. If you want to write, you write, otherwise you don't. This is binomial theorem. Here, if you put n equal to 7, you will get this sum. If you put n equal to 5, you will get this expansion. All these expansions can be obtained by using Newton's binomial theorem. Okay, in this Newton's binomial theorem, we have defined another term which I told you is the representative of all the terms. I mean this one. This is the representative of all the terms. If you say that, we will write it by using sigma symbol. Sigma means it is r equal to 0 to n NCR x to the power n minus r y to the power r, then this is appropriate. Put r equal to 0, what do you get? X to the power n, y to the power 0. It is the first term indeed. If put n equal to 1, it will be x to the power n minus 1, y to the power 1. Put n equal to 2, it will be nc2 x to the power n minus 2, y to the power 2. And for the last one, r is equal to n. Ncn is 1, x to the power 0 is 1, y to the power n. This is the final term. Okay. So Newton's binomial theorem will help us to find the expansion of any binomial when positive integral indices are there. Okay. Now in this binomial theorem we will make few observations which we have done before. Here number of terms after expansion going to be what? N plus 1. That I told you earlier with those examples. If it is 7, just you count here 1, 2, 3, 4, 5, 6, 7, 8. For 5, how many terms are there for 5? Again you start counting, it is 1, 2, 3, 4, 5, 6. So if index is n, number of terms after expansion will be n plus 1. Number 2, the general term. The general term in the expansion is, which term is this? I told you this is going to be the representative of all the terms. Which term is this? It is the rth term or r plus 1th term. That we have to decide. To decide it, you go back there. If it is NC1, then going to be the coefficient of second term. If it is NC2, it is going to be the coefficient of third term, but NC2 you got. So this is going to be r plus 1th term. Okay. So the general term is tr plus 1, which is nothing but NCR x to the power n minus r and y to the power r. This is the general term of the binomial expansion. Number of terms you got and the general term you got. And general term is the representative of all the terms that you have understood. Third observation, equidistant terms from beginning or from the end have the same binomial coefficient. Okay. Why? Because you can remember this property that NCR equal to NCN minus R. This is a formula in binomial in combination, and you have seen that here second term from beginning, second term from end, 7C1 is equal to 7C6, isn't it? 7C1 equal to 7C6. What about this thing? 7C2. 7C2 is 7C5. And what about C3 and C4? That also. 7C3 equal to 7C4. So coefficient of equidistant term, 7C3 is which term? From beginning 1, 2, 3, 4. Fourth term, and fourth term from the end is 7C4. They are equal. Why? Because NCR is NCN minus R. Keep all these observations in your mind. Now we are going to learn some important expansions by using the binomial theorem we have just learned. Okay? Expansion like x minus y to the power n. Okay, I keep x plus y to the power n in front of you, rewriting it once more. X to the power n, nc1 x to the power n minus 1 y plus nc2 x to the power n minus 2 y square plus ncr x to the power n minus r y to the power r, this plus y to the power n. I told you this can be written as sigma r equal to 0 to n ncr x to the power n minus r y to the power r. Okay. Now in this expansion, if we have replaced y by minus y, so let us do the expansion of x minus y to the power n. What you do there is just replace y by minus y. It is x to the power n plus nc1 x to the power n minus 1 minus y plus nc2 x to the power n minus 2 minus y whole square plus ncr x to the power n minus r minus y to the power r, this plus minus y to the power n. So alternate plus minus terms are coming here, nothing else. X to the power n minus, this minus is being forward, nc1 x to the power n minus 1 y plus nc2 x to the power n minus 2 y square, and third term we have written, next one will be negative dot 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 dot, not writing all the terms, the general term you take care, ncr minus 1 to the power r x to the power n minus r y to the power r, this way plus. So here we can write this as sigma r equal to 0 to n ncr x to the power n minus r y to the power r minus 1 to the power r, I am writing in the beginning. If you just write minus 1 to the power r in the beginning, then it's alright. Okay. So this expansion is possible. Alternate plus minus will come. With the symbol sigma, we can write this. Now what will happen if we want to write 1 plus x to the power n and then 1 minus x to the power n? To write 1 plus x to the power n, we will remember this one. This will replace x by 1. Just replace x by 1 and y by x. Replace x by 1 and y by x. In this expansion, whatever you get, rest it will repeat. So 1 to the power n is 1. 1 to the power n minus 1 also 1, and y is x. 1 and then x square because you have replaced y by x. NC3x cube, NCR x to the power r. This we can write by using sigma symbol. If you write sigma r equal to 0 to n, NCR x to the power r. See, I told you this is going to be the representative of all the terms. NCR, the general term, is the representative of all the terms. Okay? So you can write that manner, and here if you expand by using this formula which you have written there, it is going to be what? Just 1 minus NC1x like previous one. NC2x square minus NC3x cube x to the power r plus minus 1 to the power n x to the power n. Okay. Another very important observation I am going to tell you. How many terms are there if we find the addition of, say, x plus y to the power n plus, how many terms will be there in this case as well as in this case if we subtract? Because some problems are there which will help you to get the answer very quickly. How many terms will be there in this case? Let us first get it by expansion. It is x to the power n plus nc1 x to the power n minus 1 y plus x to the power n minus 2y square plus this way I am not writing all the terms, and this plus I am writing the second one, x to the power n nc1 x to the power n minus 1 y plus nc2 x to the power n minus 2y square. Okay, write one more term, minus x to the power n minus 3y cube plus this way. And here also you can write the next term only, that is nc3. Even I am not writing the general term, nc3. If you add these two, what is the result? On addition, it will give you x to the power n. These two get cancelled. This and this. This and this. So it will be nc2 x to the power n minus 2y square. Then it will be nc4 x to the power n minus 4 y to the power 4, this one. And here also if you expand it, what will you get? If you subtract, then it will be 2 into nc1 x to the power n minus 1 y nc3 x to the power n minus 3 y cube nc5 x to the power n minus 5 y to the power 5, like this. Now, how many terms are there if somebody has asked you in the first case and in the second case? First case means this one. How many terms are there? And how many terms are there in this case, that we are going to find. So if n is even, one case will arise. If n is odd, then another case will arise. If n is even, let us go by case 1. Case 1 is n is even. When n is even, then how many terms you get? If n going to be even number, because you see for n equal to 2, there are 3 terms, that 1, 2, 3, second term getting cancelled, first and third. So there will be 2 terms over there. If n equal to 4, 5 terms are there, then second and fourth getting cancelled, 3 terms will be remaining. Am I correct? So in the first case, when n is even, here number of terms was 2n plus 1, here also 2n plus 1. So number of terms after this expansion going to be n by 2 plus 1 in the first case, and n by 2 in the second case. You take any expansion where n is even. Just for simplicity, I am writing it very fast. X plus y cube plus x minus y cube. If you add, what will you get? X cube plus 3xy square, and plus you are doing 3x square will not be there. The remaining terms get cancelled. Okay? If we have taken n is, we have taken, n is even, we are taking. Do it with 2. Do it with 2. If it is 2, x square, y square, 2xy, x square, y square minus 2xy. So this will give you just x square plus y square. How many terms are there? 2 by 2 plus 1. Similarly, you do it for 4, you will get that. N by 2 plus 1 is the form. In the second case, why it is like this? Like if you subtract, it will be only, see, x square 2xy plus y square. From it you subtract x square minus 2xy plus y square. These two terms getting cancelled. Answer will be 4xy. I mean 1 term. So it is 2 by 2 only. Just 1 term. This is true for any even index. 2, 4, 6, 8, whatever. So number of terms will be n by 2 plus 1 in the first case, n by 2 in the second case. Now, in this case, when n is odd, what will happen? Keep x plus y whole cube, which is going to do an x minus y whole cube in your mind. Then you can get your answer. When n is odd, in both the cases, number of terms after expansion going to be n plus 1 by 2. X plus y whole cube you write, no, 1 expansion, 3c1, or it is 3x square y, 3xy square plus y cube. Okay. So if you add, you will get 2 terms. If you subtract, you get 2 terms. So that's why I have written number of terms 3 plus 1 by 2. You can test it with n equal to 5 also. So the formula, the terms, expansion, binomial theorem, whatever I told you, it will help you to do sums from there. Today I have promised you to solve some simple problems by using binomial theorem. So let us do it. Expand x plus 2y to the power 6. How will you expand it? X plus 2y to the power 6. We'll remember that binomial theorem in our mind, that a plus b to the power n concept. It is a to the power n plus nc1 this way it continues. So if you try to expand x plus 2y to the power 6, here is x and n is 6 and b is 2y. So it will be x to the power 6, 6c1 x to the power 5, 2y, 6c2 x to the power 4. You just remember that when you are expanding, some of the indices should be equal to index given here. 5 plus 1 6, 4 plus 2 6. It continues this manner. 6c3 x cube 2y cube, then 6c4 x squared 2y to the power 4, 6c5 x 2y to the power 5. If you expand it, you can't add because all are dissimilar terms, you will not be able to add. This is 6c1, you know 6, it is 12. 15 into 4, 60 x 4y square. 20 into 8, 160 x cube y cube. 6 c4. 6 c4 is what? 6 c4 has same value as that of 6 c2. So this is going to be 15 only. 15 and 16. 6 c4 is 15. 16. 15 and 16 multiplied 160 and 80. 240. 32 plus into 6, that is 192 x y to the power 5. This plus 64 y to the power 6. This is the expansion of x plus 2y to the power 6. Okay. Now suppose a question arises this manner. Using binomial theorem, evaluate 10.1 to the power 5. You have to get it by binomial theorem only, not by using calculator. This you write 10 plus 0.1 to the power 5. Then go on expanding. It is 10 to the power 5. 5c1, 10 to the power 4.1. 5c2, 10 cube. 0.1 square. 5c3 10 square 0.1 cube. 5c4 10 into and then 0.1 to the power 5. 10 to the power 5 you all can easily write its value. So 1 and then 5 zeros. 5c1 is 5. 5 and 10, 4.1 is 10 cube. So 5 into 10 cube, that is 5000. This plus this is 10. 10 into 10 to the power 3, that is 10 to the power 4 by 10 square, it is 100. This plus 5c3 also has value 10. 10 cube, it is going to be 1 plus this multiplication 5 into 10 into 0.1 to the power 4. 5 simple is 5. So it is 50 into 10 to the power minus 4 plus 10 to the power minus 5. Isn't it? So this you write 0.05 plus, now add all these. By adding you can add easily, that you get 105.00501. Okay. So 10 point, not only 10.1 to the power 5, there may be 9.8 to the power 6. You have to change your strategy. You will write this as 10 minus 0.2 to the power 6. Go for binomial expansion and do it. Not only that, question may be like finding 102 to the power 20. Again you will write this one is 100 plus 2 to the power 20. Such a big calculation. Hope you will not be asked, but if they ask, then you can get its value. Question may arise this manner also: which one greater, 1.3 to the power 6000 or 1800? How will you answer this? You go for binomial expansion. 1 plus 0.3 to the power 6000, its expansion. If you expand it 1 to the power 6000, I will be using the expansion of 1 plus x to the power n, which you have seen as 1 plus nc1x nc2x square, like this. So you just write a few terms. 6000 c1 into 0.3, this will give you 1800. If you write 6000 c2 0.3 square, not required actually, just expand. This is 6000 into 0.3, that is 1800 plus a positive term. I mean, whole positive expression will come. Whatever 6000 C3.3 cube, 6000 C4.3 to the power 4, whatever there, you don't care, because they asked you to compare with 1800. So you are getting 1800 plus a positive quantity. Even 1 also there in the beginning. So 1.3 to the power 6000 is greater than 1800. Question may arise this manner also: using binomial theorem, prove that this is divisible by 64. 3 to the power 2n plus 2 minus 8n minus 9, you have to link with binomial theorem. Then this proof is the easiest one. By using principle of mathematical induction, you can prove it, but this is better method, more elegant than the other methods. Okay, so we'll be using binomial theorem to get it very fast. 60 to the power 4. See the way I am answering here, taking this expression 3 to the power 2n plus 2 as 3 square to the power n plus 1. I can write. So this is 9 to the power n plus 1. 9 to the power n plus means 1 plus 8 to the power n plus 1. So this you write 1 plus n plus 1 c2h square c3h cube, this minus 8n minus 9. So you write 1 plus n plus 1 c1 is n plus 1 only. This will be n plus 1. You keep it this manner, because I found that it is going to be divisible by 64 even if I don't change all these terms. Minus 8n minus 9. You see, 8n plus 8 plus 1 is 8n plus 9, get cancelled with this. And from remaining term, you can get 8 square as common from anywhere. N plus 1 C2, n plus 1 8 to the power 2 plus 8 to the power n minus 1. Okay. So we can say that this expression which we have started with 3 to the power 2n plus 2 minus 8n minus 9 is nothing but 8 square 64 into this positive quantity. Why positive quantity? Because nc2 is never fraction. N plus 1 c2 is always integer, not a fraction, given this one. So 64 into something, it is divisible by 64. Thank you.